Greetings, everybody. This is Ali Yusuf, and today I'll be looking at augmenting manufacturing and in terms of how we can implement such AR technology in the manufacturing sector, and looking at how an example such Microsoft HoloLens can affect that positively or negatively. So in terms of the motivation and need here, in the manufacturing sector, there is a lot of evolution and revolution happening around the technologies that are being utilized on the shop floor. And the main goal here is to try to enhance the efficiency of the processes and enable the personnel on the shop floor with a lot of accurate and efficient tools to enable them to do their job better. One of the main key factors here and one of the new technologies that are enabling such efficiencies are AR technologies. And one of the tools that are currently on market that stands out is Microsoft HoloLens 2, which I'm trying here in this study to try to evaluate them and see how they affect efficiency and accuracy on the shop floor. Some of the main motivators here is to trying to look at the enhancement of the efficiency and the accuracy, trying to look how the learning curve can be affected by using such new technology, how collaboration can be enhanced, and what are some of the challenges with integration such new technology can be, and how does the global advancement utilizing such tools can affect the manufacturing in the future. So for the study design, there have to be some objectives. There are four main objectives that I'm trying to look at here in this study. Number one, the efficiency and accuracy enhancement. And I'm trying to compare this AR technology with standard operating protocols, aka SOPs. I'm trying to see how the learning curve is getting affected using AR technology versus standard SOPs. And as well, I'm trying to see how collaboration can be enhanced or hindered through utilizing the AR technology. And lastly, trying to see what some of the key challenges that could be faced when trying to integrate such technology in the manufacturing sector. So for any study design, there have to be key research questions. Four main questions that target those four main goals. Number one, how does this integration of the AR capabilities affect efficiency and accuracy compared to the SOPs? Number two, what is the learning curve associated with such adoption and how can be mitigated if it's high? In what ways does this AR technology can facilitate or hinder the collaboration with manufacturing personnel on the shop floor? And what are some of the key challenges encountered when it comes to integrate such technology and how it can be addressed? So number one, we have to talk about the methodologies and how we're going to be collecting data in such study. So number one, I envision this to be through observational studies where we're trying to observe people who are utilizing the AR technology on the shop floor versus only using the standard operating protocols, aka SOPs. The second part is to trying to perform surveys and interviews for the manufacturing personnel on the shop floor and trying to see how it's easy to use, how collaboration is being affected, and what are some of the challenges that are being faced when trying to implement such new technology. And lastly, there have to be some quantitative part of it, where we're trying to assess the performance metrics that are standard per that industry. So for example, it could be production rate, errors rate in terms of defects or deviations, and task to completion time, aka time to competency, and trying to evaluate the efficiency and accuracy in that realm. So after we collect the data, there have to be some types of analysis. The number one type of analysis that I think they're going to be addressing efficiency and accuracy is comparing those two groups, that one group that utilize the AR technology versus those who use the SOPs, aka standard operating protocols, and trying to compare the error rate between both groups and trying to look at how much production rate is being affected. So for example, for group one that's using the AR technology, aka the HoloLens 2, we see that I speculate here they could have 300 units per hour and only 2 errors per 1,000 operations. Versus on the other group who are only using SLPs, I'm speculating they could have 250 units per hour and they will have 5 errors per 1,000 operations. The second type of analysis that I'll be looking at as well is the thematic analysis. We're essentially trying to look at the learning curve. And we're trying to see what's the average time it takes. It could be in hours or days for personnel to achieve such proficiency with the HoloLens and compared to the SLPs as well. So an example, I speculate that there'd be 10 hours for proficiency with the HoloLens versus 5 hours. So I'm saying that it would take twice the time to be proficient with it. And as well, in terms of integration challenges, to try to understand this, I will be proposing to look at it from a categorical perspective and trying to categorize it from a technical, user resistance, and lack of training perspectives. And lastly, in terms of data analysis, I'll be looking at how there could be a collaboration analysis, and I'm trying to look at it from the perspective of how much it takes for personnel to collaborate with others versus using the SLP and the HoloLens or the AR technology. So here it could be there are 20 collaborative interactions per week, meaning there are 20 interactions with people per week, and it takes about 30 minutes if they use the AR technology, versus only 10 collaborations if using SLP, and it takes less time per interaction. So how are we going to evaluate this? Number one, we'll be evaluating the impact on the efficiency and accuracy through looking at the performance metrics between the two groups who are using the SLPs and the AR technology. We're going to be looking at how long it takes to be able to be proficient with the AR technology. And as well, we'll be looking at how much of interactions is being affected or hindered by the AR technology. And lastly, we're going to look at the themes and the categories that are created from the feedback we'll be gathering from the surveys regarding integration challenges. What are some of the expected outcomes that I'm seeing here? I'm going to be speculating there'll be a high notice in an enhancement in the efficiency and accuracy through the integration of the HoloLens. I'm expecting that there's going to be a large learning curve when it comes to implement such new technology, and it might take longer time to adopt. I look at the collaboration facilitation. I think it's going to enable and foster a more collaborative culture in the manufacturing sector. And as well, there might be some challenges regarding the integration, just because depending on the resources that the company that is trying to implement it is based on it. So what's the value of this? This will enable a new framework and a smoother technology adoption in the future for any technology related to AR if industries start to think about that from a manufacturing perspective. And as well enable manufacturing processes to be much easier for people to get used to and trained on easier. And as well, if there's any new advancements, we'll be able to add them as add-ons on such technology without having to go through a lot of standard operating protocols from scratch. Now, if we want to look at this, how this relates to what we're learning in Info 150, this comes back to the Beyond Wiser paper that I have looked at, and specifically looked at the fourth generation and trying to merge that connection between the cloud, the crowd, and the shroud. So we see with the cloud, there's a limitless computation of storage offered by the cloud computing platforms that the Microsoft Lens is based on. And this will provide a platform for real-time data analysis and sharing in the manufacturing environment. That's an example of a cloud. In terms of the crowd, I see this being implemented in terms of the collaboration nature of the modern manufacturing realm, where they can be able on the shop floor be able to utilize such lenses and as well to interact with personnel. And in terms of the shroud, such integration with a wearable technology in the manufacturing setting exemplifies that layer, and it connects between the digital and the physical realm from an AR perspective, not a VR perspective, with a seamless interaction between human and digital data. And this will enable us to get into that fourth generation of technologies where collective computing have direct applications in our lives. And I think that directly enhances and reinforces the content that we are learning here in UBCOM. And here's my references. Thank you.